Hi there, this is the solution to the cube problem. Notice the first arrangement has 8 cubes, the second arrangement 45 cubes, the third arrangement 112, fourth arrangement 209, and the fifth arrangement 336 cubes. And notice there is a common pattern here as far as the difference between these numbers are concerned. 45 minus 8 is 37. 112 minus 45 is 67. 209 subtract 112 is 97. 336 minus 209 is 127. So notice these differences keep growing by 30. That is indicative of a quadratic growth, if you will. If you just look at the simple quadratic sequence where n is 1, 2, 3, and 4, and then the value of the sequence would be n squared. So the first term would have a first value in the quadratic sequence being 1. Second term would be 2 squared, which is 4. Third term would be 3 squared, which is 9. The fourth term would be 4 squared, which is 16. You can see that there is a common difference or a pattern to the difference between successive terms of this quadratic sequence. This difference is 3, this difference is 5, and this difference here is 7. So 4 minus 1 is 3, 9 minus 4 is 5, 16 minus 9 is 7. So you can see that there's a constant difference in which the terms of this quadratic sequence are growing here. And so this common difference, which represents the growth rate of the successive terms of this quadratic sequence, okay, is evident with our sequence here too. Common difference being 30 for the growth rate. Another way you could determine that this sequence definitely is a quadratic in nature is by plotting the associated points. 1, 8, 2, 45, 3, 112, 4, 209, and 5, 336. And if you plot these points in the plane where you call the horizontal axis your n-axis and your vertical axis the use of n-axis, you can see that these points appear to lie on a quadratic graph or a parabola. Okay. So now using these points here, 1, 8, 2, 45, 3, 112, we should be able to find the coefficients A, B, C for a quadratic function here. So using point 1, 8, where the first coordinate is n and the second coordinate is u of n, we would set u of 1 equal to 8 and then let n be 1. And so we get this equation. We get this equation here. Then we let n be 2, and so u of 2 would be 45, and n would be 2, and we get the second equation. Then we let n be 3, and u of 3 is 112, and we get this third equation. Now it comes down to solving this system of 3 equations and 3 unknowns a, b, and c, and then we will have our quadratic relationship or function that models this quadratic sequence here. So how do we solve for a, b, and c? Well, we have a system of 3 equations and 3 unknowns. I'll call this equation 1, 2, and 3. Suppose I pair up equations 1 and 2, and then I multiply equation 1, both sides, by -1. That will give me a new equivalent equation number 1. And then when I add that to equation 2, c is eliminated, and I end up with a new equation I'll call equation 4, which is 3a plus b is equal to 37. I'm now going to pair up equations 1 and 3 and also eliminate c between them. So pairing up equations 1 and 3 and then multiplying the first equation by -1, we would get this new equivalent first equation here, which is -a minus b minus c is equal to -8. Adding that to equation 3, c drops out, and we're left with this equation, which I'll call equation 5. Now I pair up equations 4 and 5, and so I pair up equations 4 and 5, and then I choose to eliminate b. To do that, I multiply equation 4 both sides by -2. in which case I get this new equivalent equation, negative 6a minus 2b is equal to negative 74. Equation 5, I slide underneath this equation, and I add these equations together, and b is eliminated, and I finally get it down to one equation, one unknown, of which I can now solve for a, and I get a is 15. Then choosing this equation 3a plus b equal to 37, I then feed 15 back in for a, then I can solve for b, which gives me b is equal to negative 8. Now I know a is 15 and b is negative 8. I can choose any one of my original equations, which I'll choose equation 1, put the values of a and b in there, and solve for c, and c is equal to 1. So therefore, our quadratic function, which models this quadratic sequence, would be 15n squared minus 8n plus 1. Now when you factor this quadratic function, you get this right here. And this represents the number of rows that are added each time, times this is the number of columns that are added each time. So like if n is equal to 1, our first arrangement, u1 is going to be equal to 3 times 1 minus 1 times 5 times 1 minus 1. So that means we've added for the first arrangement, we added 2 rows and we added 3 columns. Let's see, we added 4 columns, my bad. So we added 2 rows and 4 columns. Now, for the second arrangement, when n is equal to 2, u sub 2 has us adding 3 times 2 minus 1 rows, which is to say we added 5 rows, and we added how many columns? 9 columns. For a total of how many cubes? 5 times 9 are 45 cubes. This gives us a total number of cubes of 8 cubes. Total number of cubes, 45 cubes. The third value in our sequence, when n is equal to 3, means we added 3 times 3 minus 1 rows, which means we added 8 rows by 5 times 3 minus 1, or 14 columns. And 8 times 14 gives us 112 cubes. Fourth arrangement, n is equal to 4, means we've added 3 times 4 minus 1 rows, which is to say we added 11 rows by 5 times 4 minus 1 columns, or 19 columns. And 11 times 19 gives us 209 cubes. Finally, the fifth arrangement would have u sub 5 cubes, which means we added 3 times 5 minus 1 rows, which is to say we added 14 rows by 5 times 5 minus 1, or 24 columns. And 24 times 14 gives us 336 cubes. So there you go. That's the complete analysis of this problem here. Hopefully that does help out.